We're going to begin by going back a little bit, just kind of making sure to catch everybody up to where we are. Now, in this class, everything you need is in Google Classroom, or at least I want to try to make sure it's there. So you can just go back and look at the previous day's assignments to see what you need to do. So here's Google Classroom. If you're logging in to go to this class, you're going to see there's 3 tabs across the top. There's Stream, Classwork, and People. Okay, so over here on the Stream tab, you'll see things that are helpful things. It's not really things that you're going to have, at least for a grade, for the most part. I try not to put things that require a grade over here, but you know, sometimes things come up. I don't know. I can't promise you, but I'm generally going to put things that are done for classwork and homework here, labs, things like that are all here. But in the Stream, then I say those graded things are going to be in classwork, and the Stream is for things that'll help you, but they're not things that I'm going to give you a grade for. That doesn't mean you shouldn't read it. You absolutely should read it. There are things that are there that are going to help you, okay? So this article here I put in here I thought was pretty interesting. Okay, you might want to read it, about a Google Doodle for today that was about a famous chemist. How to use Cam Scanner. And you need to have both Cam Scanner and Google Drive apps on your smartphone. If you're going to download those, download Google Drive first. That way when you download Cam Scanner, it will recognize that Google Drive is there. That's what usually happens anyway. So this tells you how to scan with your phone your homework, so it's easy to read and you don't lose points because I can't tell what you wrote. It's clear. And so you scan it with this app on your phone, and it's a free app. Make sure you choose the free version. There is a paid version. You don't need it. So download the free version. You scan your paper homework or paper classwork or paper lab work, whatever you have to write out, that can be scanned with this app. You directly from the app, inside that program, you're going to upload to Google Drive. That's why you have to have Google Drive on your phone. But you don't have to open up Google Drive. You can go to computer then, and this shows you how to paste those images into reports. Okay, now, having said that, while you don't have to have Google Drive on your phone, that would be a good idea. I'm sorry, Google Classroom on your phone, because I want you to have Google Drive. You don't have to have Google Classroom on your phone. It's not required, but it sure is helpful, because some assignments in here can be done with those 3 apps, and you don't need to have your computer. But you're given a computer, and you're going to be able to use it, and some things you really just need a computer for. But if you're doing paperwork, homework that has to be turned in on Google Classroom, you can use Cam Scanner and then load it directly in the Drive, and you can use a Google Classroom app on your phone to load that or transfer that saved document, what you put in Drive, into Google Classroom, and so you turn it in without having to actually bring out your computer. But it's up to you as to whether you choose to do it that way. Okay, that's what those are for. So like I said, things over here aren't for grades, but they sure are helpful and will help you make your life a lot easier. And I want your life to be as easy as it can be. A lot of students find chemistry to be a difficult and onerous subject. I hope it's not, but whatever it is, I'm trying to help make it as easy for you as I can. Okay. Let's see. If you're ordering lunch, and you're supposed to order lunch every morning during first period, okay, I've given you the lunch order form right here. You don't have to ask me for it. You don't have to go look for it. When you get to school, go ahead and order your lunch. It's right. This form is right here for that purpose. Okay, just click to open it up, fill it out. Make sure you click submit at the end, and you're done. This is a list of where your principals list and guidance counselors list is on this document here, and then links to their email addresses, because you can't just ask to go see your guidance counselor or principal anymore. You have to email your guidance counselor or principal and they will call you when they can do so and maintain social distance. Okay, another interesting article about why the U.S. is one of the only major industrialized country in the world that is not on the metric system, that primarily uses what's called the old imperial system. If you're going to the bathroom or nurse or your principal, or you have to leave early or come in late, you sign in and out here. So you have that on your computer. You can do it on your phone. It's a real simple, again, it's a Google form. You answer the questions, and some of them are multiple choice. Just click, type in your name, type in your first and last name, you're ready to go. Well, actually, you still have to come get a pass. You cannot leave the room without a pass. You have to have a signed pass. Now, in order to try to avoid me signing things and putting my hands on them, I've, as much as possible, tried to produce, and I'll put it on the camera down here too, produce already signed passes, so that I can take my gloved hand and pull one of these passes out, and then you're going to fill that out. Just fill in the date, your name, and the reason, time left on there. Okay, so this way there's less likelihood of passing along something that nobody wants to have. All right, so you got to sign out on that, and the reason you sign out on that record, out of class record, it's kind of protects you, and it protects me. Let's say you're down in C wing and I gave you permission to go down there for some reason, and somebody saw you down there and was checking with me to verify that I gave you permission to be down there, I would have a record of it right there. So it's kind of looking out for you, but it also looks out for me as well. I can tell them, yes, I'll let you go down there. Maybe there's some reason not to let you go down there, or I'll let you go down there, or I'll let you go to one place and you went somewhere else. There's, it's all, that kind of keeps up with things, okay? The textbooks, we'll talk about that in the units. You have an opportunity to earn extra credit on tests by studying the text, and you can see me about that if you want to. All right, now let's go over to classwork, because this is where the things are where you're going to earn grades. Okay, there's some extra credit down here. You can read through that. It's important. This is where I put the textbook in the unit, where you can earn extra credit on tests. But in order to do that, you have to annotate, and there's instructions for doing that in the document. So just read what it says, or come and see me, or if you want to have a online Google Meet, sort of a video chat on the computer, we can do that, and I can explain all these things to you. It's also already been recorded for you in the first day's instruction. This is the instruction from the first day, and it's numbered, all the things we tried to go over on the first day. Of course, they threw some things at us that I wasn't expecting. I thought I had things kind of timed out reasonably well, and they said we had to do something that we weren't expecting, so that took up a lot of time. And so now some of these things became homework, and that says down the bottom down here where it says what the homework is. Anything we didn't cover in class becomes homework, plus one other thing. I'll sort of zoom through some of these things real quickly. You can either fill out a paper signature sheet. That's this packet of things here. I tried to hand out paper copies to everybody, or you can fill it out electronically, just filling out an electronic form. If you're doing the paper form, then both you, that is to say the student, and the parent have to both sign the same form. But if you're doing the electronic version, the student goes through and does the electronic form and hits submit. Then the parent can go through, or vice versa. It doesn't matter which one goes first, really. But both of you have to go through, sign, check mark, all those things you got to do, and just hit submit at the end. Honesty in science is a really important thing, and so that's an article that will explain some of that to you. Again, here's a way to get the CAM scanner without using your cell phone. If you want to load it on your cell phone from a computer page, from a website page, you can do that. Here's how to download Google Drive. Again, that's for you to be able to download Google Drive to your phone or to your computer. Let's see here. This is the Google Classroom app, so you can get to that there. And then graphical analysis is the graphing tool, the online or the computer graphing tool. It actually is online, but we'll use the computer tool here. Now, the school computer should have this on there, but you can download it on your home computer if you want to. But when we do graphs, and there'll be a good number of those, this is the tool we'll use. It's made by Vernier, and Vernier is the company that produces the lab probeware, they're called. Those are probes that measure things in chemistry and connect directly to your computer to be able to collect data. Now, this document here, and let's see, this document here, this one, Candle or Not, and then this one, and you can't really see the name on this. You'll have your name on this one, not my name. I've got this on here because this is my student login. So my student login is named Student Tedder. Your name, your student login will have your name here. And the document is the Unit 1 Observe versus Infer Demo Report Part 2. So this is Part 1. This is an electronic form. No, I'm sorry, that's the video. This is Part 1. You watch this video. If you weren't in class, you watch this video and you do this at the same time. It tells you what to do. This also tells you how to fill this out. Explains everything in there. So you don't even have to be in class to do this activity. Okay? If you did the paper form of the signature sheet where the parents and the student signs on the same form, that has to be scanned with scanned with Cam Scanner, uploaded to Google Drive, and then pasted into this document. So you simply open that up, put your cursor underneath the numbers 1 through 6, I think it is, and do the process that's described in the other video on how to insert the image into that reporting document. Okay? All right, so that's everything from the first day. Then the second day, you had a take-home lab here. So the second day's activity, and remember we're on an A-B schedule right now, so A would be Tuesday for those students. The A through L students would be coming to class on A through L, would be coming to class on Monday and doing this on Tuesday. And then M through Z students would be coming to class on Tuesday and doing this on Wednesday. And so that's why there's 2 dates on here. And that's why you'll find all these activities with more than 1 date on there, because for the students, there's more than 1 date, depending on what their schedule is for them to do it. But it's an accuracy and precision lab. I gave students a copy of this packet, but you could print it out at home. And the instructions are all right there for you to do that. I put the candle demonstration in here, Candle or Not demonstration video in here again, but it really doesn't need to be here. I may remove that when you look at the actual item in Google Classroom. But that was for people that were following up on things that we didn't get to in class. That's why I put it there, because it was the next day's activities, just to make sure they were up to speed on things. There's the Cam Scanner and pasting images videos again. So really these 3 we've already talked about. They're already there on another day. This is your post lab document. So you do the lab here and you do the reporting here, and it pretty much explains itself. There's one more thing that we're going to talk about today we do in class to follow up with that, because I don't expect you to know everything about everything that we're doing in the reports at the beginning here. So I'm going to help you in class to try and get better at that and clean some of those things up. What I want to do now is to open up a document that somebody else has already produced. One of the students has turned in their work, and it needs to be corrected. There's some things that we need to fix on it, and some things you need to learn as a result of collecting all that data. So let's open up a student document and talk about how it really should look when we're all done with it. Okay, so here is a reporting document from the lab. So really, before you watch this part of this video, you need to do the actual lab first. It'll make more sense to you and help you more. We're in the beginning of the semester. I'm not expecting these lab reports at this point to be, sterling, but I'm trying to let you put in as much as you can, and then we kind of build on that, because there's a lot to this, and I can't if I teach you just one little thing at a time, you don't get the big picture. So we're trying to do both big picture and the detailed stuff all kind of at the same time. And you know what tables are, sorta. Now we're going to help you figure out how to make them more like they should be for a formal report. So looking at this table here, make it a little bit bigger for you. Not that you can probably see it fine on your computer at home, but just to make it a little bit easier. Here's the table label. Okay, the description of the table and the table number goes at the top of a table. It has to go on top. Now, sometimes in textbooks you'll see it in other places, but I want you to always put it at the top. That's sort of like the standard, the way that it's typically explained to be done. This student put table and then described it this way: testing how the height of dropping an object affects how far it bounces. This is a pretty good first effort. Okay, what I want to do is improve that though. So let's do that. Let's fix what we did before, how to make this better. All right. So here's a little bit better version of that. It shouldn't just say table, but it should be numbered. If you have more than one table, you've got a table 1, and then a table 2, and then a table 3 if necessary. But you put table 1 and a period following the number of that table. And back up just a bit more here. All right. So testing how the height of dropping an object. The table isn't the testing. The table is a list of all the measurements for that. Okay. So it's measurements when testing how the height of dropping an object. And then what that's about is dropping an object and how that might affect how far it goes, comes to rest from the target. So you've got a target as part of your lab. You make the target. That's 4 pages you sort of tape together to make that target. And you measure how far it is from that center dot. That's the target. Now, in a table description, so you've got a table label here, and the table label is made of 2 parts. You've got a table number, and then you've got a table description. Okay, the table description needs to have 2 things in it. You need to tell me what's in the table. So I'm telling you about the measurements of the height and how far from the target. Okay, measurements from the height and how much the target is what's in the table. And then you also have to tell me, in addition to telling me what's in the table, tell me why it's important. Well, the part that's important is how the height part affects the distance from the target. So that word might affect is the important part. That's why this table is important. You're trying to figure that out. So you're trying to keep in mind what's your goal. Okay. All right. Then I gave you a table, the beginning of a table, sort of an outline of a table, where this was all empty here, and you did these measurements, or you should have done these measurements, and I gave you 2 column labels, and then you had to do the other 2. So in the original column labels that I gave you, I used this description: distance from the target in centimeters. You don't need all of that to describe the units of measurement. Okay, just write in parentheses in centimeters, or in whatever unit of measurement it is. The units of measurement have to be in the column labels. Okay, the column labels need to describe what the data is, what the measurements are, what the observations are in that column, but the units of measurement go here not here. And you can see the student has put the units of measurement there. So all these units of measurement need to come out. And so forth. I won't go through all of those. I'm just showing you they need to come out. Units of measurement go on the column labels. I also looked at this data and I see that some of these measurements have one digit past the decimal. Well, if this number is 1 digit past the decimal, all of these need to be 1 digit past the decimal. So instead of 12 here, this should be 12.0 if it was 12.0 and 18.0 and so forth. Now in this lab, I didn't expect that you would be doing really good measurements. We'll talk about that. Right now, I'm just trying to get you to the point where you can put things in the table. So in order for your measurements to be consistent, you need to have the same number of digits relative to the decimal. So here where it was 7 centimeters, 7.0, that's 1 decimal place in the measurement, okay? It might have been, maybe it should have been measured at 7.2 or 7.5, but he put 7, so I'm making an assumption here that it's 7.0. You actually need to measure more accurately than that. And we'll talk about those measurements in a bit, okay? And so all of these need to be changed out here, all right? Now, I'm just giving you some guidance, and now you can go back and fix yours. Now, let's talk about how to do that. How do you take things out that are already submitted and fix them? Here's a student view. Okay, this is what you would see if you were looking in Google Classroom at this assignment. Okay, and we want to see what's been turned in. So I'll go to View Assignment, and this has not yet been turned in. So let's open that up. And let's say that I was working on this as a student, and I'm ready to, I finished with it, I've got all the data in there, I want to turn it in. All right, it takes a few minutes for it to load, but we'll get a little turn in button up here in a minute. Okay, so there we have turn in. I'm going to click turn in. And you have to verify the turn in. All right, but once it's turned in, you can unsubmit and edit it. Once you've turned it in, you can't edit it. You cannot edit it. It belongs to me. If you unsubmit it, then it belongs to you. Okay? The problem with unsubmitting it is this, that when you resubmit, the only date that I see at that point, at least initially, I can go and dig around in it, but I won't know to dig around in it if you don't tell me. If you unsubmit and then resubmit, then I only see the new submit date. So if that's later than the original assignment was due, I might dock points or take points away because it was turned in late. So make sure you put a note on your document somewhere near the top explaining to me why it's submitted late. And I can look at the history. I can go back in and look at the history and see that you've done all that. Just make sure you tell me that so I'll know to go look for it. And so I won't take points away from you. I want you to do that. I want you to turn things in on time, but then when you realize, oh, I need to fix so-and-so, go take it out and fix it. Okay? I want you to improve your grade. I want you to do what you can to make your grade the best it can be. Okay? All right. So let's go back just a little bit here, because I want you to be able to see what it looks like when you're going into it cold, after you've turned it in yesterday and you're going back into it and look for it. So you have to go to View Assignment, and then you can see that you've got this work it says turned in right here. So you know you've turned it in. Now I'm going to unsubmit it and verify I want to unsubmit. Now once I've unsubmitted it, then if I open it up, I can edit that document. I can fix whatever I need to fix. Okay? So that's what I wanted you to be able to see that you could do to improve your grade. All right. We want to build a graph. to insert in this report. So the first thing I want to do is to put my cursor right here, right below the table, click Insert, Page Break, or Break, and then Page Break, okay? Because I want my table, my graph rather, to be on a whole new page, all right? Now we're going to use the program Vernier Graphical Analysis. We used to use Logger Pro. It's a program that doesn't work very well with the new Chromebooks. So this one's a little more streamlined, and we're going to learn to use this to do our graphs. And so for most of the computers you're using, you're going to have on the bar at the bottom of your screen, there's a sort of a circle and a 0 in the circle on the left. You click on that, it expands, and you can see it looks like just one word. The analysis word is missing. It just says graphical. Okay, so you click on that to open up graphical analysis. If it doesn't show up there, then you need to go to Google Classroom, and I've got a link. We showed you that earlier to get to that. Okay, now it's not in this assignment, so let's go back to the beginning of this, and I'm going to go to the first day's assignment because that's where I put all those links. And there's graphical analysis. So if we go there to that web page anyway, and on the Chromebooks a lot of times it doesn't show below right here until you scroll down. So you need to scroll down until you can see Chrome Web Store. Go to Chrome Web Store, find graphical analysis, and tell it you want to load it up. Okay? So it's really pretty simple. Just follow the directions. Okay? All right, where were we? Oh, we wanted to do graphical analysis now. So I'm going to open up a copy of graphical analysis. All right. If we were working in the lab where we could connect Vernier Probeware to the computer and collect data from the lab directly into that graphing program, we'd use sensor data collection. There's also data sharing where we can share the data with other students in real time. But because right now at least we're working on things individually and we can't go into the lab area and work, we're going to do almost everything. I think something may come up, I may be able to do it a little differently, but right now I think we're going to do everything by manual entry. Okay, so what I want to do is go up here on this. Let's do this. Let's take this and make that a little bit smaller and easier to read. Go to the table and make that a little easier to read here. Okay, so I want to build a graph. So I'm going to go over here to this is not a real table because it becomes a table when you have the table labels and column labels and things like this. This is more of a chart. But I'm going to go here and click this triple dot. Well, let's don't do that yet. Let's put in the data first. All right, we're going to put our independent variable on the horizontal axis. Usually that's labeled X. And the independent variable is what you change. Okay? It can be more complex than that, but mostly in labs, it's the thing that you change. And so we changed the height at which we were dropping those little paper balls. And so that's 50, 40, 30, and 20. And the responding variable called the dependent variable. So this is the manipulated variable, that height. The responding variable, also called the independent variable. The responding variable, also called the dependent variable, is what you get out of it as a result of changing the height, in this case the independent variable. So I'll put in those numbers. So I want 50.0. And while we're right there, well, I'll tell you what, I'll come back to that. I'll hit enter. 14.1. They put in 14.05 in their table, but that's inconsistent. That is, he wasn't measuring consistently all the way through. So I wanted to make sure that I'm putting in my table a consistent set of measurements. All right. You notice when I click enter, the decimal, the 0 after the decimal place disappeared. Computers and calculators are not very good with significant digits. You need to make sure that you're smarter than the computers and the calculators are with significant digits. We'll talk more about significant digits as we go along. Right now I want to get through this and then get into measurements and where those significant digits come from, okay? All right. I want to fix the x-axis here, and I'm going to do that by clicking this triple dot thing here, and it gives me a dialog box, and I want to choose column options. All right, so X doesn't tell me what's being measured on X. So I want to change this so it does tell me what's measured on X. What we're measuring on the horizontal axis or the independent variable was the height at which those paper balls were dropped. Okay, and we measured them in units of centimeters. And I can click apply. And you can see that changes this x-axis label down here. Okay, let's do the same thing with y. The y is the independent variable or responding variable. Column options. Change y to distance from target where okay, and then that's also in centimeters. Now, not everything is in centimeters. Make sure you're putting in the units of measurement that apply to your situation. Okay, but now the vertical axis is labeled properly. I want to also label or create a table or a title here for this, okay? So I'm going to go to, let me back up here a minute. I'm going to click this icon down here in the lower left, okay? And then I'm going to click Edit Graph Options, and there's where I can put in a title. Titles are written in the format, the effect of, and then you tell me what the independent variable is. And then you write on and tell me what the dependent variable is. So it's the effect of, and the independent variable is the height on okay, and that'll give me a title at the top that's adequate. Looks like to me it's a little off the page a bit, so maybe I need to find a way to shorten this up. Effect of, I'll take out the word "the" there, of height from which paper balls, or instead of saying paper balls, because we do say that elsewhere, which balls were dropped on the distance from target let's say where they stopped. Now you can see all the title across there. Before I close this dialog box, notice these dots are right up against the edges. Sometimes those are hard to see. So in order to make them easier to see, I want to move them away from the edges. And what's hidden behind this dialog box are dots that are against this edge and this edge down here. So in order to move it off the edge, instead of starting at 20, let's say we're going to start at 19. Instead of stopping at 50, let's say we're going to stop at 52. Oh, try that again. I'm going to say 18 to 52. Okay, and that'll pull that back away from the edge. But they're also against the top here, and so I need to pull it away from what's at the bottom. We'll say 12.4. Well, 0.4, and then extend the top to 14.3. Well, try 14.3. Okay. All right, and that's pretty. And so we're going to close this out, and you can see those dots are not right against the edges here. Okay, a little easier to see. I should have left that dialog box open. I want to go back to that same dialog box. This icon is called Graph Tools. Okay, and I want to put in a curve fit. All right, and so there's the curve. In this case, a line. And when I close it out or move my mouse and click off of that, I get this dialog box here. Actually, this is not a dialog box because you don't change it, but it's a box that tells you all the values for the line, for the equation for a line. Y equals mx plus b. That's even written right there. Okay, so the data for the line is written for you out here. That's going to be part of your graph. Okay. I want you to remember that I put in 50.0, 40.0, 30.0, and 20.0 here, because we're going to talk about that later. But when I entered them, they didn't leave the 0 past the decimal, and they don't handle significant digits very well. We'll talk about that. All right, let's go over here because I want to export this now so I can put it in my report. I'm going to go to click the title up here. In this case, it's an untitled graph. Title, export. Graph image, and you choose where you want it to go. Okay, so let's see. I think in the new Chromebooks, you have the option of actually loading this document directly in the Google Drive, which is great. I don't have that, so I'm going to put it in my computer here. Let's see, I'm just going to call it height versus distance, just to kind of remember what it is, and save it. Okay, and now I have access to it. Okay, the graph itself has been saved. If I wanted to save the whole thing, I could click Save As. And that's a good idea. You never know when you might want to go back and fix something. So if something isn't quite right, you'll have at least a copy of the graph. Now it's saving as a PNG, and that's an image format. So I don't know if it's going to save the actual graph or not. This is kind of a new program for me, and I haven't really tried to do this before. I would hate for you to have to put in a whole new set of data. Okay, so going back to the report, I want to put this graph on a new page. If it's in Google Drive, that is to say, when you saved your graph, you saved it in Google Drive, you click Insert, Image, and Drive. Okay, and if you click Drive, the latest thing will be over here, so it should pop up right at the top. Since I didn't put it in Drive, and I can't, I want to go upload from computer, and that you can do that too. That's fine. And then I'm going to choose the right graph, height versus distance, open. And now the graph is in my report with a title and with the axes labels. Okay. All right. My cursor right now is on the right side of that image. Here's the image. I'm trying to click on it. Don't want to do it quickly. Okay. There it is. My cursor was over there on the right hand side. You can see it down here. If I hit enter, then now my cursor is right below it, and I can type in a figure label. All graphs, all photographs, and all illustrations have to have figure labels. Figure labels go under the figure. Table labels go on top of the figure. They go on top of the table. So the table label, if you remember, has to tell me what's in the table, tell the reader what's in the table and why it's important. The graph has to tell you those things as well, or the figure label on the graph has to tell you what those things are as well. But in addition to what's in there and why it's important, you also have to tell me what the analysis is. And the analysis is how the data, the independent variable is being affected by the dependent variable according to that graph. Okay, so let's say I have figure 1 because of the first graph or picture or illustration. Figure 1. They're numbered sequentially again, 1, 2, 3, 4, 5. Figure 1 period. So this graph shows how the height from which paper balls were dropped appears to affect the distance from the target. Actually, I should say average distance where the balls stopped. That might be good. Okay. So that's what's in there and why it's important. Now what the analysis is, it tells me the pattern. The pattern is that it is clear from this that as I increase the height, the distance from the target on average also increases. So that's the analysis. Okay, that's what it's telling me. All right. All right. So that finishes up the graph. Let's finish this report, and then we're going to talk about some measurement things. Okay. So down here, we need to talk about the photos. We need figure labels on the photos as well. So what I want to do is, rather than having 4 photos that are all kind of grouped together, I want to make 4 photos that are bigger and put a figure label under each one of them. So I could just, let's see, it looks like to me, I ought to go this way. Now, I don't know if you saw what I did, but let me back up. So if I put my cursor on this image and click once, you get that 4 corners and blue outline thing. If I press down on the, in fact, I'll put it down on the screen down here where you can see. I'm going to click the back arrow one time. Then my cursor appears between those 2 photos. I want to hit enter, and that puts that photo on a separate page. I'm going to hit the right arrow here, and the cursor is between the next 2 images. You can see it blinking right there. Okay, hit enter, and it's going to put the next one on a new line, and the same thing with the last one. I'm going to go put my cursor in between, hit enter, and now I've got all the images on separate lines. In order to make them more consistent, I was going to turn this image 90 degrees. Okay, so that's not quite 90 degrees, is it? All right, that's 90 degrees. And that's 90 degrees. That's pretty much set up properly, I think. And this is 90 degrees. Now, it is anyway. All right. Now, all that the student did here was to tell me that it's photo 1, 2, and 3, and that's not sufficient. You need to tell me more about it than that. And they did have their name on there. I just took their name out, so again, I wouldn't embarrass anybody. I want to erase these because I want my figure labels to be underneath the figure. Remember, photos and illustrations and graphs all are figures. Okay, so I've already got one figure in this graph. This will be figure number 2, but I want to make this bigger because I really can't see the pattern here. All right, and it's fine. You can take up a lot of space. It's no big deal if you do. All right, so now I've got where I can see what's going on, and I need to describe it. He doesn't tell me which one is which, so I don't know which one this is. Figure 1, 2, and 3. Maybe that's 50, 40, 30, 20, or maybe it goes the other way. So it needs to be more clear about what we're talking about. But I'm going to put a figure label on here. Figure 2. This photo shows the way the paper balls, or let's put not way, but where what in the world? I know what I did, but I'm not sure how I did it. All right. I don't know what height it is, so I'm gonna sort it like this. How about that? Or I could write out the word centimeters. Okay. All right. So I don't know. I'm not going to put the student's name for you to see, but basically the student's name needs to go here because, well, if that student took the picture, I assume the student did. On and what date? Okay. Well, I'm going to assume it was yesterday. Okay. And so this tells me which pattern we're looking at here. Okay. Now what that does is give you a basis for reaching a conclusion down here in the analysis, or not a conclusion, but reaching an analysis, okay? So that's what you do with all those photos. Then you can go look at the photos and make the judgments needed for the analysis, all right? So was the accuracy of The accuracy means this. In terms of measurements, a measurement is more accurate, or a series of measurements are more accurate when they are closer to the actual value. So in this case, closer to the target. So if you're looking at series 1 and it appears that the balls were closer together than with series 2, 3, and 4, then you would say that this series appears to be the most accurate, that is closest to the actual target overall on average. Okay, and in fact, the average from the table will also tell you that. Okay, and so that's what you're going to say about all of these. Okay, in this case, if I go back here and look at the graph, the drop at 20, right, appears to be less accurate than the drop at 30. Okay, so that's what I would say, that on the whole, the drop from the height of 20 was less accurate than the drop from the height of 30. But the drop from the height of 40 was less accurate than any of those. On the average, the drop from 40 was further away from the target. Precision refers to, in the case of repeated measurements, or in this case, repeated tests, precision refers to how close repeated measurements come to each other. They can be way off the target, but if they're grouped really well together, they're still precise. So that's what those pictures are going to help you to figure out. Let's see, there's a dot, and I don't know which one this is actually, but if I look at that pattern and they're not evenly spread, but they're grouped together over here, they're precise, but they're not accurate. Okay, so that's what I want you to do with this activity, is try to understand the difference between accuracy and precision as it applies to repeated measurements. Now, having said that, there's another kind of accuracy. Actually, there's more than one kind of accuracy and precision. We're going to look at a type of accuracy as it applies to the measurement device itself. Okay, so I'm going to zoom in here really close. And let's measure the width of this piece of cardboard. Okay, so I want to put, this is a tape, a meter tape. Okay, and if I'm going to measure it, I need to make sure this line right here, where the start of the measuring section is right on that edge. Okay, and see where it comes out over here. All right, I wonder if it would make it any easier to tell what's going on if I put a piece of white paper behind it. Might be. Let's do that. Okay, so I've lined this up. Well, on the camera it doesn't look like it, but from the vertical perspective it appears to be this line right here is dead on that edge. Well, it looks like it now. I've pressed it down. We'll do it from the camera perspective a little better, so you can kind of see. There we go. It's really the shadow we're looking at, but that's okay. I want you to be able to tell what's going on. Oh, I moved it now. Back again. There we go. All right. So let's see where we come out over here. All right. So you can see the edge of that cardboard is just slightly more than this marking. Actually, a good bit more than this marking right here, and a little less than this marking right here. So let's see. Here's 10 centimeters. Each of these are a tenth of a centimeter in between. I know that because this is 10, this is 11, that's 10 markings in between. So 1, 2, 3, 4, 5 is right here. 6, 7, 8. Okay, so the edge of this cardboard here is between 7 and 8. What we want to do in order to get the most precise measurement, so measurements are different when we talk about precision. The more precise a measurement, the finer, the smaller the markings are to give you the tighter, a more precise measurement. Okay, if I've got a ruler here. This ruler has centimeters and half a centimeters on the top here, and I'm going to turn it around. What's on the top now is measuring to 1/10 of a centimeter. So the top part of this ruler is more precise than the bottom part, as if I got it rotated here. Okay, so this is the precision with instruments refers to how tiny the measurement markings are. The tinier they are, the more precise they are. Okay, all right. I may have moved this a little bit, but here's what we got. We've got 7, 8. 5, 6, 7, and there's 8. It's in between there, and I would say it's slightly closer to the 7 than to the 8. And so it's not 10.7, it's not 10.8, it's 10.7 and a little bit more, like 10.73 or 10.74. That last digit is an estimate. Now, all the digits in this measurement, the 10.7, those are certain digits because you can tell for certain where the measurements belong. But that last digit, the one we estimate in between those markings, that's an uncertain digit. Those are terms you need to know. Certain digits, uncertain digits. And that last digit, the uncertain digit, is the estimated digit. And that's also a term you need to know. So 3 terms right there. Certain digits, uncertain digits, estimated digit. Okay? The estimated digit is always the uncertain digit. Now, this is an analog device because you have to analog. That's another term, A-N-A-L-O-G-U-E. An analog device is one where you have to figure out the measurement. That's one way to put it. A digital device has numbers on it, like my watch face, okay? So you don't have to figure this out. It's all right there for you. Even though the final digit on a digital measuring device is still an uncertain digit. I know that seems kind of strange, but it is. I won't try to get into the details because it's a little hard to explain. You just need to know the last digit on a digital measuring device is an uncertain digit, and the estimated digit is an uncertain digit. Okay? So that's how we get the best possible measurements. We always estimate one more digit than the finest marking on the measuring device. Always estimate one more digit than the finest markings on the measuring device. Okay? Now, what if we're adding up some of these numbers from that table we had up earlier? Say we have 20.0 centimeters. Now, anytime you're doing math and chemistry with measurements, you always have to have the measurement units written with a number. You cannot just write numbers down. You have to tell me or tell the reader what the measurement units are. If you know what's being measured, you also have to tell me that. That's called the species. So if this was centimeters of, well, let's say it was grams of table salt NaCl, I'd write GNaCl. So you have to tell me what the number applies to. You can't just tell me the number. So 20, and then 12.0, and then 18.0, and 4.5. And I want to add those together. I get 54.5 centimeters. Okay? Now, I was telling you earlier that when you put this into the graphical analysis, that 0 didn't show up. That's also true with your calculator. If I put in 12.0 20.0 and hit equals, the 0 on the end disappears. Do you see that? Let me try that again. 20.0. There's some glare here, so I'm going to turn it just a little bit sideways and hit enter for you, and the 0 disappears. So calculators and sometimes computers don't handle significant digits very well, and you have to be smarter than the calculator or the computer or the graphing program. Okay, and that is a computer, but that's okay. I'm going to do another series here. 20.0 centimeters, 12.0 centimeters, and 18.0 centimeters. If you add those together, your calculator tells you you have 50 centimeters. But you need to know that all of these were measured to the 10th of a centimeter, so this answer also must have a precision of a 10th of a centimeter. What happens then when you're adding up different numbers and they all have different precisions? Let's say something like this. 20, move over here where you can see it on the screen, 20.15 centimeters and 12.2 centimeters and 1.813 centimeters. Now what I've done is to line these digits up so that everything's lined up by that decimal place. That's required. I can add those together and I get 34.163. The number of digits past the decimal tells you something about precision of the measurement. When you're in a math class, you're instructed to put zeros here and 2 zeros here to keep everything lined up. We don't do that in the physical sciences, because when you put a 0 on there, you're saying this number is more precise than it actually is. So we can't put numbers there. If you want to help to keep things organized, aligned, and that's what those zeros are for anyway, then use something like an arrow. I do this all the time. Line everything up to keep everything clear. Well, we don't know what that number would have been if it had been measured with a device that would have measured to 3 places past the decimal. Nor do we know what these 2 digits are. So we don't know what this number really ought to be. It's going to be wildly off. Basically, both these numbers we have no clue about. And it really does affect this number. So we're going to, this is actually the uncertain digit. Sorry, let's see, uncertain digit. These are insignificant digits. These are the certain digits, okay? Because this digit here, the least precise one, tells us what the uncertain digit is, what the certain digits are. These 2 right here are certain digits, and anything that's beyond beyond in decimal place terms, beyond the least precise measurement, those are insignificant digits. Well, we don't want to keep the insignificant digits. We don't know what they would have been anyway. So the way we show we're rounding off is we use an arrow. All right, and this 6 is 5 or greater, so it makes that 1 round up to a 2. So our rounded off answer will be 34.2 centimeters. Your final answer needs to be in a box. Okay, now that's not, I'm not going to give you count off points if it's not in the box, but if we're doing a lot of calculations, and we will be doing a good number in this class, it's helpful for me to know where your final answer is so I can find it quickly and then backtrack and figure out what your work is, because you always have to show me all your work. Make sure that you, if at all possible, try to remember to put a box or a rectangle around your final answer. So I should have a rectangle around this answer here and one around this answer here. Okay. So when you're adding or subtracting, always line your digits up vertically. Line them up by the decimal place. Any digits resulting from empty slots, so in this column right here there's 2 empty slots, in this column there's 1 empty slot. any digits in the answer resulting from empty slots become insignificant, or they are insignificant, they don't become insignificant, you underline the insignificant digit, you draw an arrow to show you rounding off, and then give me the final rounded answer. Just because we want to talk the same language, you need to know the first digit that remains, this 2 here in this case, is the uncertain digit, and the remaining digits to the left are the certain digits. Okay? All right, let's talk about, this is addition and subtraction. There are other mathematical processes, and for most of the semester we'll be talking about mathematical processes of either addition and subtraction or multiplication and division. And most of our multiplication and division problems will be those that involve multiplying fractions. We'll do that now so I can show you how that works as well, and there'll be some rounding off for that too. Okay, the density of silver is 10.5 grams per milliliter. Okay, so the density of silver is 10.2. I'm sorry, I said 10.5. 10.5 grams per milliliter. Okay, so that's the density of silver, and the symbol for silver is Ag. Okay, that means that 10.5 grams of silver equals 1 or even 1.00 milliliters of silver. Okay. All right. So suppose we have 2 milliliters of silver, and I want to know what the mass of that 2 milliliters of silver would be. I'm going to take that 2. I'm going to say 2.00 milliliters. Okay, that shows me I've measured on a device that will give me volume measured to the hundredth. This is the 10th. This is the hundredth. The hundredth of a milliliter. So we have 2.00 milliliters of silver, and I want to find out how many grams should that be. I'm going to put that over 1, and the reason is I'm going to take this fraction here, and I'm going to turn it into a conversion unit or a conversion factor. So what I want to do, since I know this, I'm going to build a fraction here, and I want to put on the bottom of this fraction the matching measurement unit and everything that goes with it. This side, this is called an equality statement, and the right side here, in this case, has the same units of measurement as the starting amount I have on the top here. So I'm going to put this stuff on the bottom, 1 milliliter of silver. And the other side goes on the top, 10.5 grams of silver. And we're going to do the math. So multiplying by 1 across the bottom just gives me the same thing. Well, so all I really need to do is multiply what's on the top. Okay? So let's use the calculator and find our answer, all right? So 2.00 times 10.5 will give me 21 grams. But wait, this has 3 digits, this has 3 digits, so our final answer needs to have the same number of significant digits. So if I don't have 3 on the calculator, if I don't have 3 in the math, I need to put a 0 there to show there are 3 significant digits. Now this number can't be written without the units of measurement, and in this case there is a species. I've got silver here. Now, just like x's and y's in algebra, milliliters can cancel. Silver can cancel. That tells me, and this process is called dimensional analysis. This grams of silver It's what I have left. Okay? And so that's the answer. That's how many grams of silver there are, or should be. Well, there is, but if it's impure, you kind of know it from that. That's how many grams you'll have if you have 2 milliliters of silver. Well, let's do that a little differently here, okay? Suppose I have 2 grams of silver. How many milliliters is that? Okay. Well, now I need to put grams on the bottom here, not milliliters. So the 10.5 grams goes at the bottom, and the 1 milliliter silver goes at the top. Grams cancel, silver cancels, so that comes out to be 5.25 milliliters of silver. And I don't have to do any rounding off because now I have the same number of digits. Now, why didn't I consider these ones? Why did I only consider these 2 numbers, okay? These ones are counting numbers, like 1, 2, 3, 4, 5, 6, 7, 8. Counting numbers are not used.
Teachers, this is a reminder for students that